Okay, so those are and then we'll call this, actually, let me change this polarity here. Since this is VSB, so that's your bulk. And this one I'm going to reverse because this is VSB. So that way giving a positive voltage will give a negative substrate to bulk voltage. So we'll call this VSB. So this is VSB. Let's keep this consistent. Okay, so this is VSB, and we'll name the node. So let's call this D1. This will be D2. Let's call this bulk. We're not measuring any current through the bulk, so we'll keep it same. And let's call this node D. Okay. All right. Okay, now just a quick question before I proceed. So we want to operate this in the saturation region, right? Because ID in saturation region is what? Mu n Cox over 2 W over L VGS minus VT square. We'll neglect the lambda term for now because that's a correction term. So it will not give you a huge error. We're trying to get level 1 model, right? Now, what we want to do is we want to extract the parameter, right? We want to extract this, which we call KP, and let me call this VT0. So we want to extract both the VT0 and KP and gamma as well, right? So what we're going to do is because this is a square term, we want to first linearize it. So we want to plot it in such a way that it is a linear relationship. So if I take, for example, 2 times root ID, right? Then it will become KP root over times W over L root over times VGS minus VT0, right? So now if I plotted VGS minus VT or VGS versus 2 root ID, then I should get a linear term, right? So I'll get a something like that, okay? And this is 2 root ID, and this is obviously VGS, right? So obviously you can see because it's VGS minus VT0, which means that when ID equals to 0, then this intercept will be equal to VT0. So this intercept will be equal to VT0. And then this slope is equal to this value here, right? Which is root KP times root of W over L, or in other words, KP, if I want to find out, then it's that slope square times L over W, right? So that's how we're going to find this. So VT0 we're going to find from the intercept, and KP we're going to find from the slope, and obviously L and W, but L and W obviously we know. And we're going to keep the sizes same as in the assignment. So we'll keep it 5 by 1 and 5 by 1 here. So this device, like I said, this is the device we're going to use to extract the parameters. And then what we're going to do is we want to create a level 1 model and instantiate another one with that, and then compare it. Okay, both this curve as well as the lambda curve. Okay, so basically this will be our SC MOS N device, right? This is from the technology, the BSIM 3v3 model. And this one we're going to create a level 1 model, and let's say we'll call it SITN. We'll call it our own name. This will be the level 1 level 1 model, and then we'll compare the drain current versus VGS as well drain current versus lambda. Okay. Okay, so now that you have done problems and you're all expert, now tell me quickly, someone, why connecting the gate and drain assures that it is always in saturation? Yeah, go ahead, Praveen. What's okay? Looks like
Yes,
that was
sir.
a mistake.
Yes,
Yeah, go
sir.
ahead. Why is it so? Why is
In the
connecting the gate and drain always make sure that it is whenever it is on? Obviously, you have to first switch it on. Whenever it is on, then automatically it is in saturation. Why is that so?
we know that in the saturation that the criteria VDS is greater than VGS minus VT.
Right, that's the condition required. Okay,
Yes, sir.
right.
And if we do, if we bring out that VT here and VDS here,
Say that again.
bring that VT to the left side and
Okay,
VDS.
so VDS minus VT is greater than VGS.
VDS plus VT. Yes.
Sorry, VDS plus VT. Okay.
So bring this VDS to the other side.
Okay, so VT is greater than VGS minus VDS.
VT is greater than VGD. VT is greater than VGD, sir. VGS minus VDS we can write as VG minus VD.
VG minus
VD.
V.
Because the source potential will be cancelled
Right.
in those.
Okay. So basically you're saying since gate and drain are together, this is equal to 0 and VT is always greater than 0. So that's the condition, right?
Yes, sir.
Okay, good. Yeah. So the other way to look at it is like, you can just look at it intuitively. Your VDS needs to be greater than VGS minus VT. But if VDS is equal to VGS, then obviously is always greater than VGS minus VT because VT is a positive number, right? So that's the way. So exactly. So that's the reason why it is always in saturation. Now, obviously, since you're varying the drain, your drain current is varying because of lambda, but that's a small current compared to this current here. So that can be neglected for what we are doing. Okay. So that's why whenever we connect, so this is typically in analog world at least called diode connected transistors. Okay. The reason it's called diode connected transistor is from BJT, because in BJT, if you did the same thing, you connected base to the collector. This is nothing but just a PN diode, right? So that's why it's called, a lot of times you'll see it's referred to as a diode connected device. Okay. So you guys, those who haven't, draw the circuit
So what is
and
that? So what is
yeah,
that
go.
5 mu over 1 mu?
What is that? Which one?
Sir, that is
That's a
written over.
size. This is W over L.
Okay.
Because in the assignment, this is the W over L taken. So I'm just keeping it the same to make your life easier. That's your W over L. Let me put it in a different color so that. So W over L equals to 5 by 1. Obviously, we'll keep the same here. Okay. So I'll leave this slide on for a minute or so. Just those who haven't, copy this because we're going to use this node references to build the circuit. Okay. Actually, I'll also go ahead and draw it because I'll lose this screen. SP. Oh, so the gamma equation, right? So gamma is, I think you already guys. So VT, if I write the complete equation, VT is equal to VT 0 plus gamma times square root of 2 phi f plus VSB minus 2 phi f, right? So then gamma is equal to VT at whatever VSB you're measuring minus VT 0 divided by this term here. Okay. So that'll give us VT 0, KP, and gamma. Everyone good with this slide, or anyone wants to still copy some stuff? All right, let me go ahead to the next slide and then we can come back. And okay, so for the lambda, so for NMOS lambda, we're going to keep constant VGS and then vary the drain voltage, right? So in here, we're not going to change the substrate. So substrate and source, we're going to, so this is going to be VGS for us. And we'll do the same thing where so this will be M1, this will be M2. So this is the one we'll use to extract. So this will be SC MOS N. This is the one we'll create the model. SITN is what we said, right? So we'll do the same thing again. We'll put a voltage source here and we'll call it VID1. We'll put a voltage source here. We'll call it VID2 and to measure the respective one. And then we're going to, just like before, we'll have VDS, which will vary both of them. So here the VGS will keep it constant and vary the VDS to get this curve, right? And what we're interested is in this part here, where in saturation, the current is what? The complete, with lambda now. We wrote the saturation current. Now it's going to be W over L, excuse me, VGS minus VT0 square or VT square and times 1 plus lambda VDS, okay? So I think you've seen the textbook how to derive this equation. Derive the lambda by taking two values and deriving it from it. But I'll show you another way, which is used a lot of times, just quickly. Now, if you look at this current, let's call this current, let's say VID0. So this is the current when VDS is equal to VDSAT. Okay, VDSAT, which is equal to VGS minus VT. Okay, that is right at the onset of saturation, right? At this node, this is because at that time, we are not considering the lambda value. Now you saw that when Santanu was doing the model equation, this lambda is also put in linear equation, and that's because, like Santanu was saying, to avoid discontinuities. Otherwise, what will happen is your equation till will have a certain current. At this point, there will be a slight jump, but that slight jump is enough for simulators to fail. Okay, so so if you consider this ID 0, then I can write this as ID equals to ID 0 times 1 plus lambda VDS. And if I do DID over dVDS, then this is equal to lambda times ID 0, right? And this is this slope here, right? So if I maybe magnify this right now. So let's say we get this plot. And so our equation is dID over dVDS is equal to, which is equal to the slope of this saturation line, not here. Okay, not here, just at the saturation point. So that's your slope here. This is the slope is equal to lambda times ID0. So which means lambda is equal to the slope over ID0. Now you might say, oh, how do I know ID0? Now I have exaggerated this, but there is very little difference between if your lambda is small, which you're going to assume that it is, there is very little difference between ID0, even ID max. So even if you take any current value here, like you just take this value, you'll be pretty close to your real number. Okay. So when we do hand calculation, usually that's how we calculate. We just take the slope and just take any number, like you typically on the lower side better. But if you to go low, you go too much on the lower side, you might hit the linear region and then your error will be larger. Okay, but it'll be clear when we do the measurement. It'll be clear. Oh, let me name the node names here. So we'll call this D. We'll call this G, and we'll have D2 and D1 like before. Okay. Any question? Excuse me. Any questions so far? So what we'll do is from the previous one, we'll see for what values of VGS. So we'll pick like 2 or 3 VGS values for which we know we'll get, not crazy current, like manageable current. And we'll use those 2 or 3 values to get a family of slopes. We just need one slope, but I think in the problem statement that it's written how to get a family of slopes. So that's how we'll do it. And then we'll just measure one slope and get the lambda. And then again, we'll do the same thing. We'll create the model with that lambda and put another device here, and we'll compare it. Okay. So I'll give you guys a few minutes to redraw this. If somebody needs time, I'll also draw it here, just in case I lose it. Okay, everyone clear? Can you proceed, or anyone? Just raise your hand if you have questions or need a little bit more time with the slide. Okay, good. Looks like you guys are okay. Ashwini, you have a question or you need more time to note down?
So I have to note down.
Yeah, okay. We'll wait. We'll wait another minute or so.
Done, sir.
Okay, good. All right, so let's now let me share the lab. Okay, so if you guys haven't started, yeah, so I see some people complaining about blank screen and all that. So I think what they've done is they have made an auto shutdown after 12 hours or something like that. So it might be shut. So that's why don't, when you have a file open in VI, you should close it right away after you're done. If you leave it open and the system shuts down, Vim creates what's called a swap file where it keeps all the history of things you're doing so that your edits are not lost. But then if it crashes, then you just have a hanging swap file. So what you do is you open Vim and it will say, do you want to open recover? You can do recover. So it will read the swap file, save it, and then go and delete that swap file. And the swap file name is the same name of the file. It starts with a dot in the beginning. So if you're editing, for example, inverter.sp and the system crashed or something happened, then there will be a swap file called .inverter.sp, and you need to just delete that. Otherwise, it will not allow you to edit it. Okay, so let me start the system here.
Sir, even if I directly cancel it, it's stopping, sir. What to do then?
Say that again. What's happening?
Even if I directly crossing the whole window, that start stop is means it's stopping. It's deactivating.
I don't get it. What do you mean by start stop stopping when you cross the window?
Sir, after
I
doing the code in the Linux,
yeah.
after the completion, when I click means directly exit it, then also that start stop option is deactivating.
It shouldn't. Anyone else having the same problem? You must be shutting it down, or you're, I don't know. That should not happen. So basically you're saying when you're disconnecting, it is stopping.
No, sir. Means after completing the code, I directly close the whole window, like whole Chrome.
Okay. Yeah, shouldn't happen. Um, I don't know why it's happening for you. Is anyone else having the same problem? I mean, it's not really a problem. You can always come back and just restart it, but it should leave the instance running. The code, the user interface is just a link between the Linux. It's running on something called Docker container. So the Docker container is kind of independent to this. It's just communicating, but you closing the window should not close that. I don't know why it's happening, but it's not, it's not a huge problem. Just come back and start, or just leave the browser open. Maybe it's related to your Chrome. Okay. All right. So let me start the desktop. Just increase this size a little bit. Okay, everyone can see my screen. Okay, so now we are going to go into the lab directory. And so we did lab 1 or whatever you called your before. I'm just going to create another directory called lab2. So everyone can go ahead and do the same thing. mkdir lab2. Okay, and we'll do cd lab2. And here you can name the tabs. So let's name the tabs. So we'll call this tab netlist. Okay, because we're editing the netlist, so let's call it netlist. So you can see it's written netlist here. Now let's open another tab, new tab, and we'll name this NGSPICE. NGSPICE. So now you can see netlist and NGSPICE. So let's go back to netlist. So let's start a fresh netlist. We'll call it Vim maybe extract VT. It's VT KP gamma, but I'll just keep it VT to just keep it simple, and SP. Okay. So the first line is a title. So we'll just give some title, extracting VT KP gamma for NMOS. Okay. Now what should be the next one? And today what we'll do is we'll try to add comments as much as we can. So to make your programs readable. So the comment line usually, so the first line in NGSPICE, you can either give asterisks or not, it doesn't matter, it'll automatically be taken as a title thing. But from then on, if you want to give a comment, you have to start with the star or the asterisk, okay? So first thing, what should we do? We should call the library file, right? Or include the library. Include the SCMOS library. Anyone remembers the, and get into a habit of writing the SPICE commands in capital, because then that way it's easier to see. Now you have Vim, which is color, makes it color, like you can see it made it yellow color, but you know, you may open it in another editor. So it is useful if you you know, make the commands in capital, because then you know it's a SPICE command. So what is the path? Anyone remembers? Okay, I'll show you a little trick in Linux, how to get that path. And you have to be careful with this command. So exit. Okay, you're here now. You have that file. You know the ls command, right? So if I want to find out where that file is, so I do ls, right? Project 2020. So I do just PR and tab, it automatically completed it. If I forgot what the next one is, I can do tab. You can see it is EDA. Then I do tab again. Then it is should be NGSPICE. So I just type NG tab. It automatically completes it. Then I do tab again to see where should I go. I think it's in models. Oh no, just this one, right? SCN. Is this the one or is it in models? I think it's in models. Models, okay. So you go to models, okay. So in models, you see scmos bsim4.lib, right? So that's the file we want to call to instantiate the library. Now, if I just press ls, you can see it actually printed out the entire path and the file name, right? Over here. You can do copy paste over here, but I'll show you another Linux command which you should be knowing, but it is a dangerous one. So you have to be careful with this command, okay? So what you can do is you can hit the up arrow key, okay? And this is the command. Now you do greater than, and it's very important you do two greater thans. If you do one greater than, you're going to overwrite the file. Two greater than is append. So basically what it is saying is that whatever is the output of this command before the greater than, take that output and append it to this file, extract vt.sp. Okay. So it'll take it to the very end of the line and append it. So I'll repeat again. It's, let me do this first. Okay. So if you just did ls, right? You did ls, it printed that whole line /project 2020 EDA. What I want to do is I don't want to type this or copy this again. I just want to take this output and put it into the file. Okay. So the command for that is greater than. So that will append it. If you just do greater than, then it will override the entire file with this one line. So that's why I said it's one of the dangerous commands, but it's a very useful command. You know, if you know, it'll make your productivity pretty high. Okay, so let's open the file again. If you open the file, extract.sp, you can see this whole lib got appended to the entire file. Okay. Now I want to move this to the top line. There is another command in Vim, Shift J. Okay. It is Shift J. If you do Shift J, it will take the next line, remove the new line, and concatenate it. Okay. So I'll show you again. So let's say you had 2 or 3 lines before this. You take the cursor to .lib and just keep putting Shift J's, and it'll just keep removing the new lines and start concatenating them. Okay, that's it. So you do that, and usually I think NGSPICE doesn't require the code, but a lot of SPICE simulators do. So I'll put the codes around the file name. Okay, and I think the nominal is called norm, so I'll do a norm. Now, there's a very powerful command in Vim to see if what is this file. You can just open it straight in this window, whatever the file name is. But I'll not show it to you right now because you guys are all going to kill the browser window because it involves the control signal. I'll show you maybe later sometime. Okay. Okay. So we have the library files. Save it. Shift W. Save it. What's the next one? What should we do next?
Include temperatures.
Temperature. Okay. Temperature, it will keep it nominal. So yeah, so we can write the temperature. We'll keep it nominal for now. So if you ignore it, it is by default. By default. So 27. So this is by default. You don't have to write temperature if the temperature is 27. Okay. So by default, it is 27. Okay. Temperature. What? So we'll start commenting everything. Set the device temperature. What's next? So this, what's next?
Parameter.
Okay,
Nothing.
who's
Parameter.
Krishna? Parameter. Okay. What parameter do you want to put? Do we have any parameters we want now? So yeah, parameter will be next, but we are not going to be using any parameters now. So we'll skip that. What else? Yeah, Ashwini.
Sir, there is a problem in my window.
Problem with what?
My terminal, sir.
What's the problem?
Sir, on entering the vim extract dot bash rc.
No. What is .bashrc doing there?
No. Extract something like that. It is given.
Yeah, just a file name, extract.sp.
Yes, sir. Then after entering that, I'm not coming to the netlist window.
What is it opening? Where
It's
are you?
just-
Which directory are you in?
It is lab2. It is showing just.
Okay,
And
so
then-
you did vim extract.sp, right?
Yes, sir.
What do you get?
So just a blank terminal I'm getting.
Of course, it's a blank terminal because I also got a blank terminal. That's why I started typing all this, right? So you have to type all this now.
Nothing is written. So netlist window is not there. Just like
At least because I named it. Because I named it. I named the tab netlist right now. Okay, so you have to name the tab. Otherwise, it will come with some number.
okay.
Okay, so you have to name it. Anyone else? Okay, so what should we do next?
Write the schematic netlist.
Schematic netlist, good.
Model.
So what we'll do first is we'll extract the parameters from this library. Okay, we'll use the device from this library because this has a BSIM 3v3. It's like got a model which is very accurate to the real device. So we'll use that to extract parameters and then create the model file. So let's skip the model file right now. Let's extract the parameters first. Okay. So all right, so netlist. So like Praveen said, let's write the netlist first. And this netlist is the netlist of your main circuit. Okay. So whatever, so typically, you know how you did your EDA playground, right? You wrote your Verilog code and then you wrote a separate test bench. Now what we are doing is our test bench and our circuit is actually the same because it's a very small one. So in the netlist we'll include the entire thing, but as we do some, even when we start doing the inverter, we'll get into the habit of creating the circuit and instantiating the circuit in a test bench, because that's how you're going to do, if you are in the VLSI world, that's how you're going to do for the rest of your life, right? So we'll get into that habit. But right now the netlist is very small, so we are going to use just the same thing over again. Okay, so we're going to use the name for the first. We'll start with the MOS transistor. So one MOS transistor. So we said we're going to name it as M1. And what's the first node? Is it drain, gate, or source, or bulk?
Right.
Drain, right? And the drain name is D1, right? And what's the gate? D1, 2, right? It's the same. And what is the bulk name? We called it D, right? And the source is 0, right? SCMOS N is the model name, and we're going to call W equals to 5 micro, L equals to 1 micro. Okay, you can see here I put a tab between all the nodes. When you're writing in hand, it's a good practice, because that way if I have a second device, let's say, you can actually see, you can have a node name which is 4 or 5 characters, and you can see, okay, all the drains and the gates and the bulk in one place. So it's a good practice. Okay, all right, so now let's put the 3 voltage sources. One is VDS, then the current measuring VID1, and then the source to bulk voltage VSB. Okay, so we'll name VDS as we put in the netlist, and VDS positive node is D, negative node is ground if you look at your netlist, and the DC value is equal to, we'll give some value like 5 volts, right? So that's the DC value. So this is for DC operating point. When you don't give any analysis, if you give a DC analysis, okay, not a DC sweep, but a DC analysis, this is the voltage it is going to apply. So you always have to give a DC voltage. So it doesn't matter, it does a AC analysis, a transient analysis, a DC sweep, it will always require a DC voltage. Okay, so VDS, and then the current measuring is VID1, and the VID1 positive terminal is at D1, negative terminal is D, and this DC value should be 0 volts because this is an ammeter, right? So there should not be any voltage. Then the source to bulk voltage, the positive terminal is ground actually, and the negative terminal is bulk, and this one DC will just keep it 0 for now, right? So that's it, right? That's your entire netlist. Okay. Okay, so our netlist is complete for the first device where we are going to extract the parameter from this M1. What should I do next? What are the other sets of commands now? Now the netlist is complete. I have the library. I've set the temperature. What should I do now? I have to tell
Parametric variation.
parameter
VGS
variation. We
value.
don't. Yeah, VDS variation, or what we have to do is what's called in SPICE language analysis. Okay, now we have to tell what analysis do you want to do. Do we want to do DC? We want to do transient? We want to do SC? Want to do DC sweep? What transient, what analysis we want to do? That's what we are going to put here. Okay, so what analysis do I have to do? I have to do DC sweep. So DC sweep command is what? What is the DC sweep command? Anyone? Yeah, Krishna, what is the DC sweep command?
Sir, VTS.
Yeah, but what is the command name? Is it .dc or DC or what is
Sir, dot DC.
.dc? Okay, .dc, good. And what are we going to sweep? VDS, right?
Yes, sir.
We're going to sweep VDS, which is also VGS in this case. And what are we going to sweep from? You want to sweep from 0 to 5 volt, step size of, let's say 0.01. Okay. Or did we do 0.01? Okay, let's keep it very fine. We'll do 0.01. Okay. So that's your .dc sweep. What should we do now? So that will vary the BCD. So are we done or anything else?
Dot control network.
Dot control, correct. Now that's in, you have to remember that, 1 second. Okay. So now we want to, so you have to remember the dot control is actually very specific to NGSPICE. So there are a lot of SPICE type simulators like Smart Spice, Head Spice, you know, Eldo and all those. They're SPICE based simulators. But most of these commands will be actually very similar in most SPICE simulators. But the control, dot control is very specific to NGSPICE. So if you're using another SPICE simulator, this will not work. But we are obviously using NGSPICE, and in NGSPICE language, it's called actually the NGSPICE script. Okay, so this is where you actually write the script of controlling the netlist now. So this is where you control the netlist, and you end the control with .nc, and then finally end the entire schematic with .end. Okay, and here we are going to give all the commands for running this netlist. So what's the first command I should give?
Is run.
Run, right? So we should do run. And then once it's run, what should we do? We should plot it, right?
Got it.
Plot. And we're going to plot what? The branch current of VID
Versus
1. And again, this hash branch is again a very I hope it's not rebooted. Okay, good. Yeah, hold on. Yeah, I think I have a network issue. Okay, so versus V of D, which is the drain voltage, right? So that's my entire script I'm going to run on this netlist. Everyone fine with this? Yes, Ashwini, what's the question? You have a question, Ashwini? Okay. Okay. So everyone fine with this? Any questions on this one? I think.
Sir, can you please again tell that ls command?
Oh, ls
So-
command?
Yes,
Yeah.
sir.
So what I'm saying is that, so let me do it in another example. Okay.
Yes, sir.
So let me create, so you can just create it directly. So if I do just ls, right? It is doing a ls extract.sp, whatever is the output of ls, and it's just not ls, anything you're doing, let's say ngSpice run, you do greater than, whatever comes on the screen will get appended to that file. So it's just not ls. So for example, there's a command called echo, right? So for, okay, let's do this. ls, this is the file, right? So I can do ls append to, I'll call a new file called new.txt. Okay. So if I do ls now, you should see this new.txt, right? And if you see the content of this file now, you should see my content of the ls, right? In the new.txt. You see? Okay. Or let's say I want to do like there's a command in Linux called echo. Echo is just printing to a terminal. Echo hello world, right? If I just type this, it will print hello world in the terminal. You can see it. Now, if I want to put this into the same file, I do echo hello world greater than new.txt. And now if I cat the file name cat new.txt, you'd see I had this new.txt extract. Now hello world is also appended it here, or you can open it in VI. So vim new.txt, you can see all this file. Okay. So that's why I said now what you can do, you can do ls project EDA and then NGSPICE models and models SCMOS folder. So if we just did ls, obviously it will just list the file name like it has done here. Now what you want to do is you want to take that output of that ls command and append it to, let's say, this new.txt file. And then if you do vim new.txt, then you can see that this name is file. And if you want to take this and append it to this line, you do ShiftJ. But you can just, you don't have to do this. I just showed you a command. You can just go into edit mode and do backspace, and that'll also work just like a normal editor.
Yes, sir.
Okay, everyone
Yes,
got
sir.
it? Anyone wants to? Okay, so this is the complete netlist. Now we are going to run it. But before I do that, just raise your hand if you want to take a few minutes to complete the netlist. We'll go slow today. We'll take our time. I want everyone to, okay, just complete the netlist. Who else wants? Yeah,
Sir,
Sumant.
dot lib dot temp which we use, can't we use the small letters?
Yeah, you can use small letters. Like as I said, it's just a good habit to make it capital because then you know it's a SPICE command. See, now you're seeing colors, right? Which is because of Vim. All right. If I open this in another, let me just open this in. Okay, so they're typing the netlist. I'll show this afterwards. Let's say you open it in VI, just plain VI. Actually, VI is probably connected to Vim right now, but let's say you open it in another editor called Nano or Edit. And they may not have this color map for SPICE files. Vim has this color map, that's why you see it. So what happens is so this is the practice we always did in the older days, SPICE, where the commands you always type it in capital. So that way it's easier to know that, okay, this is a command actually. So it's easier to kind of see the netlist, even though if it is not colorified like this, it's easier to see them. Obviously with the color, it is very readable now. So even if I type it with small letters, it'll be. So the commands are not case sensitive, but node names are. You can't give D1 here, okay? And then give small d1 somewhere because small d1 is a totally different name, a different node name. Same thing with voltage source names and all that. Okay. Yes, Swades, you have a question? Or you just
No,
want
sir,
to
I
note it?
just need some time. That's it.
Yeah, just go ahead, note it down. Anybody else has any questions, you can ask me in the time being.
Sir, and there are two types, netlist and NGSPICE, right?
Sorry, just say that again.
There are two tabs, netlist and NGSPICE, right?
Yeah.
That one we will we will go to file and new tab and then write NGSPICE. That's all, no? Or
Exactly. No, you go to you go to tabs, and so let's say I want to change the name of this tab. I say tab, name tab, and you can see instead of netlist, if I
not
want
naming. I'm saying opening another tab.
opening another tab, you go to file, new tab, or you can do shift control T like it is in here. That's the hotkey. So you can do shift control T. That'll also open a new tab.
So this site can't be reached.
So that
When I did shift control T, it is showing this site
no.
can't.
Okay. Sorry. So that's why I'm asking you, don't do any control stuff right now. So the problem is because you're on a web browser, the shift and control commands goes to your browser first. Okay. If you want to send it to your device, then use this extensions. So you can see there is a control here. So you first do control, then do shift T. But just keep it simple and do new tab. Okay. Don't do shift control T right now because it'll
But I
go to your browser.
lost
But if you
everything.
have a desktop at home, you can use Shift Control T and that will be fine. Yeah, Krishna or somebody, Nilima, you had a question?
Sir, yeah, sir, sir, we have a problem, both Nilima and me, sir. Our screen is showing blank, sir.
Yeah, just go. It's probably somehow, I don't know. For some guys, it seems like it's just rebooting. Don't use any of the Control Alt keys right now, okay? Because that goes straight to your browser instead of your terminals. So just go to your dashboard. Did you go to your dashboard? Is it alive like this or is it black?
Is it like this? It's showing a green button and red button.
Okay, then just if you just click this desktop, what comes up?
Sir, the blank space.
Oh, it's still coming blank. It could be
Yes, sir.
that you haven't rebooted for a while and it just caught you in it. Just I would say stop it, hit the red button, shut it down, and then start it again. It should be okay.
Okay.
Sir,
Okay. Yeah.
sir, I have done that, but again it is showing.
So it's coming as blank screen again.
Yes, sir.
Okay. What are your usernames? Tell me. So I'll just send a.
Sir, Krishna.panda section9@gmail.com.
No. What is your username? Like when you log in, just like me, I have logged in, and my
Sir,
username.
Krishna Madhuchanda.
That's your entire. That's your username, Krishna Madhuchanda.
Yes, sir.
Sir, same I am getting, but again, I have done that stop and again run working. So can you do?
Yeah, just try again, but I'll send an email. So
Sir, it's working for me right now.
all right. So what's your
I'm
username,
trying.
Nilima? What's your username, Nilima?
Sir, CT05.
C
CET.
CET.
It is CET1234. Sir, I don't remember exactly.
Can you just type it your username, because he's always asking me usernames. So just type your username.
Okay, sir.
So username is the one which when you log in, like for example, this before the @ which you get this name, that's your username.
Yeah, excuse me, sir.
Yeah.
So means after means sometimes before I'm getting the colors like the from the netlist and NGSPICE, means the colors, that the yellow one and the, but after when I go out mm, from this file and again came to the Vim, means I have named that file, but
What did you
the
name the file name?
VT_KT.
Yeah, you're not going to get the colors. Vim requires that you name the file .sp. Why did you name it the other way around?
Yeah, .sp.
But first it was showing, but now how that's possible?
Yeah, just name it .sp. It'll come again. Are you using Vim or VI?
So Vim, sir, Vim. It's not
Yeah,
a...
you should get it. Yeah, either your extension is, like for example, actually sometimes it's extension, doesn't care about the extension. Depends on, it'll just read the header and figure out. But I think most of the time you need extension. Okay, so username is Nilima. So Krishna, I think your username is probably not Krishna Madhuchanda, right? Is it? Or is it just Krishna?
Sir, Krishna Madhuchanda, sir.
Oh, Krishna Madhuchanda. Okay.
Now it's working, sir. After stopping
It's
that red button, it's working.
okay. So Bijalaxmi, you also try that. Just stop it and start it all over again. I'm going to just message him in the meantime. So just give me a second here. like my network connection is. So it'll happen sometimes when your network connection is slow too. I think that's what's happening on my side.
Sir, it's showing that sourcing is failed.
Hold on a second. Which
Okay, sir.
sourcing?
Sir, in NGSPICE, it's showing that no such file in or dictionary.
Okay,
That
then
is
you
it.
just don't, you are in a different directory or you've typed in a file name. See, those errors you just have to debug, right? I mean,
Okay, sir.
it's it's a user error. It's not a tool error. Just know that, right?
Sir,
Yeah.
sir, after disconnection, means when I am connected in in netlist folder, without pressing shift key, sir, it is printing means it is showing higher case means capital letter, and when I press shift key and type something, it is showing lower case.
Your caps lock is on. Just switch it off.
No, sir, caps lock is off.
Just press it again. It's probably on. Are you sure?
Yes, sir.
Yeah, that sometimes.
Caps lock is not working inside the Linux.
You know, this could be because, hold on a second. Nobody's caps lock is working.
No, sir. We have to use Swift for that. Capital letters.
Okay, hold on a second.
Sir, shift will work, caps lock will not work. So I've checked that.
Okay, yeah. So caps lock is not working. Yeah, so you just have to shift. So you're saying the shift is not working for you?
No, sir. Actually, when I press shift, then it is printing lower. Means a small alphabet. When we leave the
Just,
shift and
yeah, so these are all related to network issues. So what happens is, because all your key is going through the network channel, if for some reason, so no VNC is not like the most sophisticated virtual terminal. So what happens is you do a shift, and if the other end does not acknowledge, then you have removed shift, but it doesn't know. So it just remains in that. So what I would suggest is just close the terminal and start over again.
Yes.
You don't have to shut it down. Just disconnect and connect it back again. And I think that should fix it. Okay. So even for people who see that, you know, you press L and it just goes L, that's because you just have a very, very slow connection to the server. You just have to have patience. So sometimes it'll happen, and you know, you just have to bear with it. Okay. So who was it for the shift one? Was it Sandhyanani?
yes, sir.
Yeah. So just disconnect and connect back again. I think it should be should work fine. If not, then let me know.
So what is the source command? I forgot actually.
Source command is source, right?
So I mean the spelling actually. That will be keep it
No, source
case.
SOURC.
The
No, sir.
command
Capital or small. That's
No,
what I
small.
asked.
We can.
small. Yeah. In the interpreter window, I think you have to give everything small. Okay. Just give me a second. Let me send this message to Napti, and then I'll get back to you guys. Okay, actually my connection for some reason is very slow too, but hopefully it's okay. All right. Okay, everyone done with the netlist? Can we proceed to the NGSPICE, or raise your hand if somebody still, how many people still want to? Okay, let's go to the NGSPICE window. And so I'm in the same directory. So you want to make sure you start the NGSPICE where you are, where you have your netlist, okay? Now you can always CD to it, but let's keep it simple. So go to your directory where you have your netlist. So I'm here in Lab2. I'm going to start NGSPICE here, okay? And then I source, and here you can use tab as well to complete the SPICE file name if you have it. And if you do that, okay. So, okay, that's, you can see the curve is inverted, right? Why is it inverted? Who can tell me? Inverted in the sense, why is it negative? Oops, sorry. Is everyone getting this negative current, or I'm the only one getting this negative current?
Excuse me, sir.
Yes.
So we are also getting.
You're also getting? Okay, who can tell me why you're getting this?
VID low polarity you can check.
Yeah, so I'm plotting VID1 branch, right? So if you look at VID, the positive is D1 and negative is D. So the positive end is on the drain side, negative is on the VDS side. So the current is going from negative to positive. So that's why it's so
So we
you need
can
to.
take note of that, right?
Yeah, but you just see, you don't fix an error with another error. You don't make even number of errors. You first fix the error. Yes, you can took mod. It's actually absolute ABS.
Yes,
So,
sir.
okay. So maybe I'll show you that. Let me show you. So if you have this, you can do, yeah, don't press this. You can do absolute. So there is a lot of mathematical commands available to you. Absolute is one of them. So you can do sine, cosine, log, and all that. So I think you should be able to do absolute. And if I source it now, yeah, you can see now it's positive, right?
Sir, in NGSPICE, while I have typed ls, I didn't get anything.
Why are you typing in NGSPICE? It's not, ls is not NGSPICE command. It's a bash command. I didn't tell you to type ls in NGSPICE.
Sir, after coming to NGSPICE, what to do? Can you please repeat again?
Source.
Source
Source is the command. So now you want to source the file. See, you see this when you type NGSPICE, you get this NGSPICE 8. This is called the NGSPICE interpreter. Okay. So in NGSPICE interpreter, you can actually type all the commands you typed in this control. So you could have sourced this netlist and type run, plot in this file. So all the things which are in control, you can actually type it here. Or you can just source the entire file and it will go line by line. Okay, so you do source extract and it will run it line by line. Okay. Okay, so you can do absolute and change it like so this was saying mod, but like as I said, don't fix an error by inverting the error, actually fix the error. Don't do two errors and get a correct result because you've done even number of errors. So
Sir,
what we're going to,
source is file name argument required.
Oh, give an argument. Why are you asking me all this question? You can't do source, right? You have to give source file name.
Yes, sir. While I've written the file name also, I'm not getting that.
Yes,
I
what
was
you have written? Source.
Yeah.
source
Source.
space that extra and the file name that we have
What
given.
is your file name?
Sir, the one which you gave only extractor.
What is your file name?
Your file name, yes.
Sir, extract hyphen.
Is that the file name you gave or not?
Yes, sir.
Okay, so what's the error? So one thing I've been showing you, you can use the tab in the NGSPICE editor as well. So if you do X tab, it will actually automatically complete it so that you don't get an error. So what's your error? Sorry, go ahead. Is it Sumant or who is asking that? Yeah,
Yes, sir.
Sumant.
Tab is not working. Like when I type the tab, no file is coming.
That means you're in a directory where there is file is not there. So exit NGSPICE and figure out which directory you are in. Okay. PWD is not going to work, but you can't figure out. You just, I think there is a command, but exit NGSPICE and figure out where you are first, because you're not in the directory where the file is there. So you just have to figure that out, right? So exit NGSPICE. Suman, can you exit NGSPICE right now?
Sir, I have crossed it.
Huh?
I have crossed it. Like
What you
NGSPICE.
crossed it?
I have crossed the NGSPICE, sir.
What do you mean by crossed? I don't understand.
Or what you are saying?
Which directory are you in? Have you exit? So just exit NGSPICE like this. Okay. Which directory are you in?
Sir, when I typed exit, I again came to that net list.
What is your directory? Do a ls.
So just a minute.
In this directory, do a ls. Do you have the netlist in this directory?
So just a minute.
Okay, while you're doing this, let me go and fix this. So I fixed the, now it is D and D1. So now the positive end is on the voltage source side. The negative end is on the drain side of the transistor. And now what I'm going to do is I'm going to do 2 times ID root over, right? Because that's really what I want to plot. So I'm going to do 2 times of this and square root of this, which is this, right? I'm going to plot that. Okay, so let me, while Sumant is doing that, I'll go ahead again, do source. Like I said, if you just type X or whatever is the name, and you just hit tab, then it should source the file. And it doesn't look right. Okay, oh, it is okay. All right. So while other people are doing it, what I'll do is I'll do the VSB sweep as well. So that way we'll just do all the extraction at one time. So how do I do the VSB sweep on top of this? Anyone? Praveen? So it's called a nested sweep, right? How do we do a nested sweep?
We'll be writing VSB there with the parametric variation.
Right. So we write VSB and same thing.
Yes,
and so we'll do 0 to
voltage and final voltage with the step value.
Right. So let's say we do 0 to 1 with the step value 1. So it'll do 0, 0.5 and 1, right? So this is called a nested loop. In the sense, it'll start with VSB equals to 0. It'll do the VDS sweep. It'll go to the next value of VSB 0, which is 0.5. It'll do the VDS sweep again. It'll go to the next value, which is 1. It'll do the sweep. So I should get really 3 values, right? Okay, let me go and run this, and then we'll stop and go one by one to make sure everyone has this. So you can see I have 3 families of plots. Okay. So you can see my plot is actually, the VTs is getting less and less and less. So what is my mistake? Who can point out my mistake? What I have done? Let me show the netlist. So because the VSB, the VT should go higher and higher. Instead of that, you can see, so I got my first VSB equals to 0 plot, but then the next one is actually going lower. So VT is actually becoming negative. So what's the mistake in the netlist?
Terminal. D1 B0.
So who can point out my mistake here in the netlist? Actually didn't do it knowingly, just, but this is how, a lot of you. So my first suspect would be that my source and bulk is inverted, right? So VSB, source to bulk, should be positive. So you can see source, I've kept it, the positive part as the source node, which should be ground, is 0. And the negative node is connected to bulk. So this is VSB, right? And it is a positive value is what I'm giving here. You can see it's 0, 1. So that seems correct. But you see over here, right, in the netlist, where is my bulk and where is my source? So this is what? Drain. This is what? Second node is? You guys there, or you just completely lost it? I have no response at all.
Sir, gate, I guess.
Yes.
That's gate, right? What is
Yes,
this
sir.
node?
Then source, then bulk.
Source and then bulk, right? So what's the mistake here?
Drain.
You see it, it's too obvious, or you're still not able to catch it?
Source. Sir, third one will be 0.
Yeah, third one, that's the source node, right? So that should be ground. And
Yes,
the
sir.
bulk is where I should give the bulk voltage, right?
Yes, sir.
Change bulk. So that's the, hopefully that's the mistake. Okay, let's fix this and run it.
Yes.
Okay, now I think you can see that. So you can see it's very closely related. So what I'll do is I'll maybe expand it. I mean, you should get the values properly with this. So you can see now this is my original value VT. So if I zoom it, sorry, zoom it. So you can see this was my original value. These are my higher values. This is for 0.5. This is for 1 volt. And I think during originals Santanu's presentation, somebody, I think it was maybe Swades, who asked, like, how do I know which one is for it? See, most simulators or these things, they will actually annotate this. They'll put a legend saying that this is for VSB 0, this is 0.5, this is 1. NGSPICE doesn't have it, or it has it. I don't know. So you just have to figure that out on your own right now. But when we do maybe in Python or NuPlot, I'll show you how to get that information. Actually, this information, I still may not get it. But here in this case, we know it because, okay, so how many of you are getting the plots now before we go to
Yes,
do
sir.
the extraction? Everyone is getting the plot? Raise your hand who are not. Okay, Ashwini, who else? Priyanka, who else? Sumant, who else? Okay, Sumant, what's the issue? Where are you stuck?
That source one is completed, but it is showing command not found and everything.
Just send a screenshot, okay? I don't know exactly what's happening. Just send a screenshot. We'll take a look at it. Okay, Shruti, where are you stuck?
Sir, my PC is broken. I gave it to the repair shop, so I couldn't do the.
Oh, so you haven't even started it, I guess.
No, sir.
Okay. Yeah, just follow the YouTube video and do it. I mean, you know, that's nothing we can do right now. So
Sir,
just yeah. How
sir,
about
whenever I
Priyanka?
press,
Yeah, go ahead. Who was this?
sir, whenever I press one time the letters, it will press 20 times. So
Yeah,
I'm
yes.
not able to complete it, sir.
No. So are you using so this is because you have a slow data connection. You might be accessing other Google and everything faster, but that's because they have proxy servers everywhere. So are you using like a mobile hotspot?
Yes, sir.
Yeah, try to go to a location where you can get a good signal. Okay, means like the side of a window or something
And
like that.
whenever I press backspace for clear it, all the things get clear.
No. So all that is issue with the network. So what happens, like I was saying, every time you send a key, it sends it through the VNC. If your network is a sloppy network, it doesn't do a good job of acknowledging. So what happens is it thinks that you're still sending L, although you have finished L. Okay. So it's to do with your network connection. I get that once in a while too. So you just have to fix that, you know, go to a place where you get a better connection, better data, or just switch to maybe another uh, you know, SIM card or something. Okay, it should go away.
Okay.
Once you fix your network, it'll go away.
Sir, I have
Okay.
sent the photo.
Yeah.
Excuse me, sir.
Yeah,
Sir, I have
Priyanka.
done the netlist code, but I don't understand how to run in the NGSPICE.
So you have finished the net list. You've saved it, right? Shift W. You've
Yes,
saved
sir.
it. Okay.
Escape from WQ. Yes, sir.
You don't have to do the WQ because we are using two different tabs. So you can keep that open and go to another tab. Okay.
Okay, sir.
And then in that tab, before you start NGSPICE, you make sure your netlist is in that directory. Do you see that?
Yes, sir. Extract the -bt.sk.
Okay. Start NGSPICE there. Did you start?
Okay, sir.
Then do source. Okay.
Yes, sir.
Sorry, source. And here you can actually use the tab key where you, for some, they're not working. I don't know why, but if you can type X and you just hit tab, it will complete the rest of the file name by itself. And then hit enter. Did that work, Priyanka?
No, sir, just a second, just a minute.
Okay, go ahead. So while you're trying that, let me, Ashwini, what's your problem? Where are you stuck?
Sir, I'm not getting the graph.
You have to tell me, so give me some clue. Why are you not getting graph? How am I going to know? What did you do and where did you get stuck?
Sir, I have completed the net list.
Okay.
So after that, what I have to do, I'm not getting.
Then why are you saying you don't have the graph? You have to start NGSPICE and then source it, right? Start NGSPICE in that directory in another tab and then source it.
Sir, can we see you?
So wherever you have your netlist in that directory, you have to start NGSPICE. Okay.
Sir, I have sent the photo, sir.
What's up? What's that, Sumant?
I have sent the photo in the WhatsApp, like command not found. I said now.
Yeah, go ahead, Priyanka. What you're saying something?
No, sir. No, sir. I'm doing.
Shruti, you're good?
Yes, sir.
So show me your netlist once. This is a bit stuck.
So, Sumant, you're not even in the NGSPICE. What are you? Where are you typing? You have a bash. You have a bash prompt. You have a extract p line. What are you? I mean, I have no idea what you're doing. Okay, you've typed source in bash command line.
Yes.
And so it is basically taken all your spice command as a bash source. You have to first type ngspice and get a command prompt like this. You know, you have to pay attention, right? You just keep typing something and not knowing what you're doing.
No, sir. After that, I did it. Like I typed
Sumant,
NGSPICE.
just listen to me. I'm looking at your screenshot. You have done source extract vt.sp in your bash command line. You cannot, this is not a bash script you have written. You have written a spice script, right? Correct, Sumant?
You have tried NGSPICE. Then, yeah.
And
Sumant,
now I got this, sir. So now.
Sumant, hold on. You've written an ngSpice script, right? Hello?
Yes, sir.
You've written an spice script, right? Don't
Yes.
go mute. I'm asking you. Just hold on there.
Yes, sir.
Okay, you've written an ngSpice script, right? Where
Yes.
should you run it?
Inside the NGSPICE.
Okay, so why were you running it in bash? You just didn't know, or what happened?
Sir, actually, sir, see the second photo that I sent, sir.
What's your second photo? Yeah, because you have written a wrong model name. So you fix that first before you go to something else. And then you have given some number. So your netlist has an issue. It's not a problem with NGSPICE. You have a problem with your netlist. Fix that. So you have written a VGS number somewhere, and your SCMOS n, instead of calling SCMOS n, you have called it as SCMOS. So that's your problem. Okay.
Sir.
Sir, can you open the list again?
Excuse me, sir.
Yeah.
Sir,
Hold
I
on.
think
Who was asking the question before? Shruti, or was it
Sir, Priyanka.
Priyanka? Go ahead. What was your question?
If you are getting an error, then how to go to like netlist command from the NGSPICE?
No. So you are using two separate windows or not? Like this.
Yes, sir. Yes, sir. Two separate
Okay.
windows.
So that's the reason, you can run everything in one window, but then you have to get out, run NGSPICE, get out of NGSPICE, start Vim. So that's why we made it easier, because this terminal allows you to do tabs. So we are using tabs, right? So if you get an error, see what the error is, right? Like, for example, I'll do an error like what Suman did right now. So what he has done is, like, one of the error he has is, instead of SCMOS n, because that's the model name, he actually gave SCMOS, right? So let's say you had this error and you went to NGSPICE and you did source extract.sp. So obviously it's going to come with an error. So you can see warning, can't find, it's actually saying warning, but it's really an error, right? Because it's saying can't find model SCMOS. Then it says error on line 10, M1D1 SCMOS could not find a valid model name. It's clear, right? You can't get more clearer than this, an output. Just read those 5 lines and you say, oh, okay, SCMOS, it's saying it cannot find it. So if you had to debug this, you had to really go into this file, right? You would want to go into this file, the model file here. And, I will not show you how to do that now, but later on, you can go into this file and you can see that the model name is SCMOS N, SCMOS P.
Okay, sir. Yes, sir.
You got it?
Yes, sir.
So just go back and forth between the terminals to make sure that
Okay, sir. I'm doing.
Okay, who else? So Ashwin, are you still stuck, or what is the problem?
Hello.
Yeah.
So when I'm pressing the new tab, I'm getting uh, the terminal
Yeah.
with my ID name written.
Yeah, that's fine. That is just for sake of clarity. You don't have to rename if you don't have. You can rename it by renaming it your name tab and rename it, and then go to your directory where you have your spice file. Okay. And then do NGSPICE. By the way, Ashwin, you just have a lot of static on your microphone. Can you?
Okay. Is it
I
okay?
don't know why. Yeah. And then type NGSPICE in that directory. You'll come to this window, which is the NGSPICE command interpreter, just like bash command interpreter. And then you type source extract.sp, and that should run your program. Like here, I made a error by knowingly, so I'm getting error. Once you fix that error, you should have that problem. Okay, I have to mute you, Ashwin. You just a lot of static.
It is showing that command not found.
Which command not found?
When I'm typing NGSPICE, then enter, then it is showing that bash NGSPICE command not found.
Why are you typing bash? Are you typing only NGSPICE or bash NGSPICE?
NGSPICE only.
Yeah, I think you have deleted your ng.bashrc again. I don't know how you're doing it, but you have done it. Just follow the instruction we gave you yesterday and just do that. I mean, come on.
Okay, sir.
Okay, how about everyone else? Everyone has the netlist running now. Can we go ahead and start doing the calculations? Just raise your hand if you need some time on this netlist. Okay, so everyone is able to run, right? Except for some of you who are still, either your PC is not working or your bash RC is completely gone. I mean, those things you just have to fix online because otherwise we'll never, get going. All right, so can I go ahead and do the extraction from the plots now? Everybody raise your hand if you want me to go ahead. How about Priyanka, Shruti, you guys are good? And Sumant, your netlist is fixed now?
Sir, I'm fixing, sir. Just a minute.
Sir, I'm getting the same error. Like when I'm typing NGSPICE in the NGSPICE window, it's showing like no such command available in NGSPICE.
I think you've done the same thing as what Ashwini has done. Is your .bash RC there, or you deleted it, or what happened to your .bash RC?
No, sir, I have opened like in the morning time. It was working at the time. But now it's showing.
Just send a screenshot quickly, and
Okay, sir.
do a ls minus a .bash RC in your home directory. Minus al, sorry, ls minus al. So type this. Both you and Ashwini, you can type this.
Yes, minus al dot basrc.
Yeah, I'll send the command. Just 1 second. ls minus al dot bash rc. This you do it in your home directory, or you can type this even if you are in another directory. Just type this and send me the screenshot.
Excuse me, sir.
NGSPICE.
Excuse me, sir.
Who's Sumant SS?
Sir, I have sent a photo. What to do? Can you please tell me? I've been stuck there. Like I'm
Wait.
not able to do LS or not able to do anything.
See, lot of errors are first NGSPICE on source extract dot extract hyphen vt dot sp. Actually,
No,
where
sir.
it is?
No. Can I delete the NGSPICE tab and then again open it?
No, just exit that, not tab. How to delete?
No. When I am typing exit, see the last lines. When I am typing exit, it is coming again like that only. See the
Put Control C.
Control C.
What you are getting?
NGSPICE 1.
Okay, so exit it. Exit that.
Exit.
So
Yes.
okay, where just write PWD.
PWD.
Enter.
Yes, sir. I am in lab 2.
You are in lab 2.
Yes, sir.
Press LS.
LS. I have only one file, that is extract.vtsp.
Okay, so check whether that file is available or not. VIM means what errors are there inside, you have corrected or not.
Yes, like what? I have to check the netlist.
Yeah, then netlist is correct.
Yes, sir.
Okay, okay. Now, okay. So where you are now? Lab 2.
Now I have to type NGSPICE.
Okay, just write NGSPICE. Enter.
Yes, sir.
What you are getting? That 5 lines.
Yes, sir. Got it.
Sorry, I lost my connections here.
Okay. So now write that source.
Sir, again I have to check something.
So source, that file name you have to give.
Yes, sir. After that, again I got some error. I have to check it again.
Okay, then check what is the error. That
Yes, sir. I'm checking again.
saying DGS is in some not defined or like that. Is saying.
Excuse me, sir. Sir, I think Sumant just wrote the file name wrong. Like he has wrote xtrsct or extrsct. Like he has to check the file name of.
Yeah. I know that. So I was typing EX only. Continuously, I was typing
Sumant,
EX.
one thing is that all your errors are because you've done typos and you're just not looking at it. Like these are, I've told you 1,000 times, these programs run the same way, it doesn't matter what it is. So I'm looking at yours. You just, your source, where is it? First one you sent here. Source, yeah. First one you've sent it straight to the bash. And then second one, yeah, it's saying can't find model name as CMOS. So
Yes.
you just have to fix that, right? And then line number 16, you have to show like you've messed up your node name or something. So for people like this, I mean, you just have to go and at least get the basics of like you're just trying to throw things and see if it'll work. I mean, it's not going to work like this, right? You have to have at least a little bit of the basic, right? Otherwise, how are you going to So Priyanka, I asked you to do ls space minus al $home dash dot bash rc. Why did you do one command? Again, just when they're saying it's not, you just have to. Okay, looks like Ashwini, you have your .bas RC. Do you have your NGSPICE definition in the end, or you haven't added it?
What's
In the .bas RC, looks like you have your .bas RC.
Yes, sir.
But why is your NGSPICE not running? Have you added the NGSPICE definition or not? Have you run NGSPICE at all or not?
No, sir. This is my. I have not done the previous labs.
I told you, you have to follow and get the NGSPICE working. Come on, I mean, this is.
Last 2 days, what you are doing?
I mean, we have been doing this since Friday.
Videos and following what?
What's that? Okay, you have to just follow. I mean, I think you don't have the path. I mean, we can't be repeating this 30,000 times now. I told you, see the video, get the NGSPICE working, right? We have the video, we have the instructions, everything is there on the web.
I will do this.
You just don't want to work.
Okay.
Okay, what about the rest? Priyanka, where, I mean, is your NGSPICE.bas RC there or not at all?
Sir, it was there in the morning time when I opened that, but right now it's not.
What about now? Forget the morning. Do you have it now or not?
I think I don't have right now.
Don't think means check.
No, I told you type the command. Just type the command. Is it there or not?
Yes, sir. Yes, sir. It is.
Okay. So what is your NGSPICE error? Just type NGSPICE and show me the error. And do a cat of your .bas RC and show the end.
Sir, when I'm typing, like one letter is repeating continuously.
That may be problem.
Okay, that's a network issue. I don't know. I mean, I can't fix that. You just have to, find a place where you have a good network connection. I was getting the same thing. I had to switch the network. Okay, so that's the I just can't fix that one right now. Okay.
Okay, sir.
How about the rest? Everyone is okay. So let me do this. I mean, we are already 2 hours in. I know some of you are still stuck. Try to do that offhand, and maybe we can do another session with you guys who are still stuck. But let's proceed with the rest of the crowd here and get it done. So everyone is okay. Let me fix this. All right, so I think what we'll do is we'll proceed now. Some of you who are stuck, we'll do it in offline. Okay, so these are the plots, VGS. So this is basically VD. VDS, VGS, actually VGS versus root of ID, right? So this is really root of milliamp is what we got here. So, and you can see it should have been a linear plot, but as you can see, as you go higher and higher voltage, the plot is, so your linear line should have been like this, and so the current is lower. And these are the short channel high field effect. Now, this is actually 0.5 micron. You typically don't see a huge amount of high field short channel effects, but you can see that you're actually seeing that. So what we'll do is to extract the parameters, we'll stay in the linear region, will not go here, because you can see if I extract from here, then your VT is going to be negative, which is unrealistic. So we are going to remain in the long channel regime over here and then extract the parameters. Okay. So I'm going to just zoom in to the mouse is difficult. Okay, so let's do for VSB 0 and VSB 1 volt, we'll take two parameters. So maybe I can zoom in maybe a little bit more. Sorry. Okay, so we'll probably, so this looks pretty linear. So we're going to take the slope and some xy y0 value here, and then calculate VT0 KP from this, and then we'll take another slope here and calculate the gamma. Okay. So what you can do is you can click one of these points here in the curve and left click, keep it pressed and drag your mouse. You can see when you're dragging the mouse, it is showing delta. So you just drag the mouse like this and maybe go till here and then release the mouse. Okay. Once you do that, then if you go back to your NGSPICE window, you see it's giving you the x0, y0, x1, y1 value and the slopes as well, dy over dx and dx and dy. But what we'll do is we'll just take two values here. I mean, three values here. We'll take the lower values. So let's take x1, y1 and dy over dx. Okay. So what I'm going to do is I'm going to create another tab here. Let me create a new tab. And I'm going to call this worksheet. And so we're going to open another file and actually write all the values there. So let me call this worksheet. Okay. And then I'm going to open another file called worksheet. Let's say worksheet.txt. Okay. And this is, I'm just going to name something. So VT KP gamma and lambda extraction for SCMOS-N. Okay, just an eye. All right, so I'm going to give a VSB for a VSB value, and X is your x-axis is what? VGS, right? So this will be VGS. That will be in volts, and then Y value is what? Root ID, right? So it'll be root milliamp.
Sir, it's a text file or a SPICE?
Yeah, text file. Just open a text file.
Okay.
Okay, and then Y value. Sorry, this is Y value, and then I'm going to calculate the slope, right? And the slope, I'm going to say a root milliamp over D root milliamp over V, basically. Because the x-axis is actually 2 times root over, right? So the unit should be root milliamp, right? Okay. So VSB 0, let's see, what was the VGS value? VGS value, so I'm going to just take one value. So let's take this one value, 0.754 volts. So 0.754 volts. And then I don't need another tab here. And then Y is 0.05. I'm going to write it in root milliamps. So this is root amps. So I'm going to write it in root milliamps. So this will be 5.968. 5.968. Okay. And the slope is So this is dy over dx. This is the slope. So slope is 24.73 root milliamp per volt. So 24 point, what is it? 24.73 milliamp per volt. Okay, so I got one value. Let me take another value. So I'll go to this one. So this is VSB1, and I'm going to do the same thing again. Left click, hold, and with the mouse drag and go to some point where it is still linear. So maybe just stay here. That's pretty linear, and then release it. Okay, and go back to the window, NGSPICE, and you get a different sets of values. So again, let's take this. So this is 0.995 volts, and this is for VSB1. Okay, so VSB1, 0.995 volts, and Y is 6 root milliamps, so that's 6.0, and the slope should be almost the same, 24.99. 24.99. Okay, all right. So we got both our values. So we're going to do quickly our calculation. So let's calculate first VT0. VT0. So what's VT0? So first we have to calculate what the C intercept, right? So let me write it here. So Y equals to mx plus C. So I'll first calculate C, which is equal to Y, which is 5.968 minus 24 point. So I'm all keeping it in root milliamp. So 20, keep this on 73 times 0.754, which is equal to so everyone just keep doing it. If I'm making a mistake, let me know. 4.73 into 0.754. So this is minus 12.67 minus 12.67 root milliamp basically, because this is the y-axis, so root milliamp. Okay, and then from here I can calculate VT0. So VT0 is when your y-intercept is equal to 0. So that is minus C over M, right? So VT0 is equal to minus C over M, which is minus cancels, minus 12.67 divided by M, which is 24.73. That is equal to 12.67 divided by 24.73 is equal to 0.512. 0.512 volts. Okay, that's our VT0. And let's just calculate, while we are here, let's calculate VT1. So which is basically VT at VSB of equal to 1. So C equals to 6 minus 24.99 into 0.995, which is equal to 6 minus 24.99 into 0 into 0.995, goes to minus
18.86.
18. What is it?
18.86.
18.86. Yeah, minus 18.86. So VT1 is going to be equal to 18. I'm just cancel the minus 18.86 divided by 24.99. What is it?
0.754.
0.754.
Yes.
0.7.
0.78 or 75?
754.
7.5.
Okay, 754. Okay, so we have VT0, VT1. Now let's calculate gamma. So what is it? Oh, KP. So we have to calculate KP2, right? So KP, we can just use that first set of equations here. So KP was what? KP is equal to slope square times L over W, right?
Yes.
So slope is 24.73. So I'll keep it in all in milliamp, 73. Square divided by 5, basically 1 by 5. So I'll just make it 5 because micron will cancel. So what is this? .73 square by 5. Okay, so it's 122.31. Okay, what's the unit?
Morning we have discussed what is the unit of KP.
Yeah, what is the unit here?
Ampere per volt square.
Exactly, ampere per volt square, because here you can see the slope is root ampere per volt, right? So if you take the square of that, it becomes ampere per volt square. And Kp is also mu n Cox, right? So mu n is what? Centimeter square per volt second, and Cox is farad. So from that also you can get ampere per volt square. But what is this now? 122.31 is it ampere per volt square or microamp per volt square or milliamp per volt square or ampere per microvolt square? What is it?
Milliampere per.
Yeah, but it was root milliamp, right? So you take the square.
Yes.
So 10 to the power minus square is minus 3 square is what? Microamp per volt square, right? Everyone got it, right? If you are confused about this, then just do the units as it is. Do it in all in amperes, and you should see this come. Just give me a second, guys. Okay, I'm back. Sorry. So everyone okay with this units here? Like I just said, if you are confused about doing milliamp and root milliamp and all that, just keep everything in ampere and calculate it. You should get 122 10 to the power minus 6 ampere per volt square as well. Hopefully that is what you should get. Okay. Um, everyone okay so far with the calculations and everything? What else is left? Oh, gamma. So let's calculate gamma. So create this text file, keep everything here. What I would want you to do is just, after you do all the simulation and all that, make this as a project, create a GitHub page, because you can put it on your resume and showcase it. I mean, this is something people do as like sometimes a semester project, like especially undergrads, right? So you have a chance now to do that. So keep all these values, write a nice like 2-page report, put it on your GitHub page and become a very nice project. Okay, so let's calculate gamma. So what was the gamma formula? It was gamma equals to, sorry, VT1 minus VT0, VT1 minus VT0 divided by root of VSB. So I'm just going to write the numbers here. Don't. What is VT1 we calculated? 0.754. Then this is 0.512. 0.512. Then root of VSB plus 2, 5. Oh, 5. We have to calculate 5, right? So anyone has the 5 value calculated already? 2 into phi equals to 26 millivolts times natural log of, what is it, Ni over Na or Na over Ni?
Ni over Na.
Ni over Na.
Okay. And Ni is, you guys know Ni. I'll give you the Na number.
Ni 1.5 in the convenience, 1.5 in terms of 10.
Do you have the Na number? It is there in this model file. You can.
So actually, sir, NCH is there, but there is N sub I am not getting. Maybe.
Yeah, NCH is N sub.
Yes. Then we can use 1.1 into 1 to the power 7, 10 to the power 7, I think. You can
Yeah,
check.
so that NCH you can use it as N sub.
Yes.
NCH is what? 1.17.
That I have to check actually.
I'll just do it 1 second. Grep minus INCH project. Oh, actually, hold on a second. Grep. NGSPICE 32. So we are getting this from the model file. So remember, this is, we are trying to model what we are fabricated. So the NCH number is known to the guy. So we are extracting it from the model file instead. Okay. So So 1.7 E17.
Okay, yeah.
1.7 E17. Okay, quickly, can somebody give me a number? So 26. So Ni is what? 1.4 E10, right?
1.45 into 10, you can put 1.45.
Yeah, 1.45 E10. And then this is
1.7.
1.17.
1.7.
Oh, 1.7, sorry.
You can change here first NCH. Yes.
Yeah, 1.7. So what's this? Can anyone give me the number real quick? It should be like 0.45 or something like that.
Sir, 0.423.
0.423.
3.
Okay, good. Oh, 2 times and 2 times this, right?
Yes.
2 times. So this is phi. 2 times this is what is it?
846.
846. 0.846. Okay. So then this will be root 1.8 because VSB is 1 volt. That's what we're taking. Root 8 1.846 minus root of 0.846. Okay. All right. So somebody give me a number real quickly. What is this? Gamma. What is this? Is everybody calculating or not? I just hear only one word. So Swades, Priyankas, Sandhyarani,
0.55.
0.551.
551.
Okay, I'll take your word for granted. Please let me know if somebody else is getting another number. Just calculate. Everyone, please calculate.
Yes, sir. 0.551.
0.551. Okay, so 2 people getting 0.551. I'll trust that. If this was a milli or 5,000 or 500 or 50, I know it would be wrong, but it is less than 1. So I think, okay. So the only thing which is left is lambda. But before we do that, we can put lambda 0 and quickly check the model. Hello? Can you guys hear me?
Yes, sir. It's audible.
Yes.
Okay, just give me a second. My screen is completely stuck. Maybe I'm running out of power. 1 second. Just give me a second, okay? Okay, can you guys hear me now?
Yes, yes.
Okay,
Yes, sir.
good. All right, so what we're going to do is save this file, Shift W. Don't close it because we have it in a separate tab. We don't have to close it. Let's go to the netlist file, right? So we're going to now create a model based on that. So now we're going to say level, let's call it SIT level 1 model. So what should I start with? What's the model start with? What's the command? Dot model, right? And then what should it be? The name of the model. Here you can name it anything you want. SIT, we'll call it SITN, let's say. And it is an NMOS model. So like I said, keywords always try to keep it capital. That way it is easier to discern it, okay? And it is level 1. And VT0 is what is the value we calculated? Okay, you guys tell me now. I've calculated. What did we calculate VT0? 0.5? What is it?
512.
Sir, are you editing the existing file?
Yes, I'm editing the existing file. You
Okay.
remember we said we are going to put the MOS in the same device and do it. But what I would suggest is copy that file to a file. That way, if you're making any mistake or
Yes,
erase
sir.
it by default so that you have the older file. But I'm existing the older file. Okay.
Yes, sir.
All right. So VT0 and then KP was what? KP is equal to
122.
122. We can just say U, right? That will be micro, and the units are assumed here. Obviously, you don't have to give units. It's ampere per volt square. And then gamma, right? Gamma equals to, what was it calculated?
0.55.
0.55. And lambda, we'll just keep it 0 for now. We haven't calculated. So we'll keep it 0. That's it, right? And now, what's that?
5.
Oh, 5, yes. 5, let's put 5 at the beginning.
846.846.
Yeah, 5 is actually 2.5, so 0.846, right?
Yes.
Okay, so that's our level 1 model, which we have derived from the parameters. Let's see how much off or how much closer it is to the BC model. So I'm just going to copy a line. So we'll call this M2, and this was drain 2, right? Look at your netlist, which you had drawn, right? We'll follow that netlist. I'm not going to go back and forth because it'll take some time. So the second device M2 drain and gate were D2 and D2, right? So D2, D2, and source is obviously 0. Bulk is the same bulk which is connected, both of them. VDS remains 0, but we need to add another current monitor for the second transistors, right?
Yes.
And that one, we'll call it VID2, which will connect from drain to D2 now. That's the current which is being monitored from D2, right? And we are going to plot now both the branch 1 current as well as the second branch current. So you can type V now and select this whole thing and press Y. It will copy the whole thing. Then do P. It will print it. So now you have a copy. All you have to do is now change VID1 to VID2. Okay. So I'll run it first, then we'll go back and I'll allow you guys to, do this. Okay, let's run this and see how close or far off it is. So I'll do the same thing again. Source, extract, SP. Something is not right.
The blue one.
I don't see the VID1. Okay, so it's plotting VID2.
Sir, will there be comma between the two plots?
Sir,
No, you don't need comma actually, just the two vectors. Yes, Santanu.
in M1, you have to write SIT10, the MOS.
Sorry, I think there are a few people talking over. So, Santanu, say that again.
In M1, the MOS name should be SITN.
Oh, yes. They're overlapping on top of each other.
Yes.
Good catch. So because I've chosen exactly the same mass, the two graphs are actually exactly on top of each other. So whichever was printed first, I think it does VID1 to VID2. So that's why. So we have to change this model name to SITN, right? Because we are testing that SITN. Because that's the new model which we have created, level 1 model. So this is the level 54 model or 49 model, I guess, right? The M1. M2 is our level 1 model, right? We want to see the extracted parameters we extracted and the handle calculation we are doing, how much is off from the real model. Okay, let's do again. Okay, yeah, you can see now. Okay. So you can see one thing you notice is, okay, so the red one. So who can tell me what the red one is? That's level 1 or level 54?
So level 1.
Level 1, right?
Level
Because
1.
it's perfectly linear. You can see it, right? Because our equation told us that it is going to be perfectly linear. That's why it's perfectly linear. So you can see at lower VDSs, they seem to be almost matching. I'll zoom in. But as you go higher and higher, they start deviating, right? And that's the place where all your high field short channel modifications, which have been being implemented over the period of time where we have level 54 and all that, is actually mostly in this area. So when you're talking about short channel, obviously your highest voltage is only 1.8 volts or 0.6 volts. So by the time you reach 0.6 volts, your fields kind of look this strong. Okay, so you can see that how much it is deviating away from our level 1 model. Okay, now let's zoom in to where actually it is matching. So I'll just zoom in here. So yeah, so you can see again here, see in the linear portion, it matches very well, right? That's because I actually took the parameters from here, and that's the place you want to take the parameter, because that's where it is really valid. The models we are doing is really valid. And same thing here, right? And the other thing you noticed at this point, sorry, this point at the lower point, you can see that in level 1, we had assuming that it is the current is 0 till VT is 0. Then after that, it starts rising in a square fashion. This is root of ID, right? So this is actually square. That's why it's linear, because the y-axis actually is root of ID, right? So that's why this is linear. But in the real model, you can see that the current really is not 0 when it is less than VT. So this is your VT. The current is really not 0. In fact, you can see it's pretty high. It's 1 milliamp for this transistor here. And this is the area which is called the subthreshold region. Okay, and your gain, your gate to current gain is actually very, very high here. The absolute current is lower, but the gain is really, really higher. So you can see for the other, VSB 0.5 and VSB 1 also, you can see that as the current goes below VT, it's not 0. It's smoothly going. And these are your imperfections, which makes the circuit not act well, in the sense that if you have this kind of disconnect, this is one transistor, that's why it's working well. But if I take this model and put like in 10,000 transistor design, you're going to have so much convergence issues, because when I take the derivative of this, it's going to have a huge slope here. I mean, huge kink here. Whereas if you look at it here, the derivative will be very, smooth. In fact, I can quickly show. Why don't I try that? I'll just do one VSB. And let's do the derivative of this now. Just taking the derivative of ID. So if you see, this is the derivative of level 1, and the derivative of the ID versus VGS for level 54 is this. You see how smooth it is, the derivative, whereas the level 1, it just has this abrupt Boom. And this creates a huge amount of problems in simulator. It works now because it's just single transistor and the tolerances are pretty high. So it works. But if you take this transistor and start doing like, hundreds of thousands or even like thousands of transistor, this, because these are nonlinear equations, right? So then they use this iterative algorithms like Newton-Raphson and so on. So they may not converge at all when you do it. So this is another reason why you go for higher levels, because they match the physical. Because in reality, it's not sharp like this. In reality, the derivatives of all the stuff is very smooth. So it matches the real device very, very precisely. Okay, any questions? I kind of went fast on this one because I just wanted to show you the difference between the models. Do you want to try it now, or do you want me to try the Lambda and maybe try this later on? How many of you were able to finish the comparison? Any of you? Raise your hand if anyone was able to finish the comparison. Okay, I think before we do the Lambda, let's do this real quickly, and at least the netlist part and comparison part. The calculation part, you just take it for assumption. So let's just go through it one by one and finish it. So everyone ready? You just want to just take your netlist which you had already done, and then add this line. So I'll just wait, go one by one. So obviously the library file we used before remains as it is, and now you add the new model, right? So let's call that dot model SITN NMOS, and level equals to 1, phi equals to 0.846, VT 0, and KP and gamma value. Okay, and once you have added the model name, add the new transistor now, and short the gate drain to a new node called D2. Keep the bulk and source same, and width and length same, because we're going to do a comparison. And add the model name SITN, which is the new model name now. I'll just scroll down a little bit. Okay. And then once you're done with that, the only thing you have to add is this new current sensor for the drain current ammeter for the second NMOS, which will be, we'll call it VID2. It's connected from D node to the new node D2, and DC value should be 0, because this should be a short, right? This is ammeter. And this one, I just, for the sake of showing you this example, keep the DC analysis the same, and in plot, add this new branch, the VID2 branch. And like as I showed you, you can just copy and paste using the command VY. V is to select, Y is to copy, P is to paste. Or you can just manually type it too. Anyone able to get the plots or having issues? Just raise your hand. So the only new thing is the model, the new MOS M2, the new current ammeter VID2, and in the plot at the VID2 branch, 2 times VID2 square root of it as well.
Sir, can you tell me what to do if the screen comes completely blank?
Sorry, someone can't hear you. What is it?
What to do when the screen comes completely blank? Means mine that no VNC suddenly stopped and the screen came blank. I was waiting for last 5 minutes, but it's like blank only.
Yeah, just go back to the dashboard and reboot it. I sent a request, but I haven't heard anything from the NAPTI guys.
I will means stop it and again play it, right?
Yeah.
Yes.
Yeah, do it. So that stop and play is basically shutting it down and rebooting. Play is basically starting your computer. So there is a small computer in the cloud where you're just going to switch off and switch on. It's probably, my guess is like, I'm not getting it at all. It looks like a lot of people are not. So my guess is like you're using some control characters which are just messing it up. That's the problem with when you're doing this whole thing on a web browser, because a lot of the keys are meant for web browser, which are also meant for the thing. And you pass it on by, on the left-hand side, you have that settings window. You'll see on the top, there is a keyboard button. If you place that, you'll see there is a Control Alt Tab Escape. So typically you want to use those, but so that's why don't use Control, because you do Control W or something like that, it'll kill your, because those key commands go to your browser, right? So there has to be a way to say, no, don't take it to the browser, but take it to my machine in the browser. So that's the problem I think most of you are facing, is that you're probably just typing escape or Control W or Control Alt, something. I don't know what's going on. But that's my guess. Okay, anyone complete yet or completed netlist but running problems, issues? Just let us know. Where are you guys?
Yes, sir, completed.
Is it Praveen?
Yes, sir.
Okay, so you're all getting plots and it's comparable and all that?
Yes, sir.
Okay, good. How about the rest? Anyone else?
Sir, please open the worksheet.
What do you want from the worksheet? It's all here in this page. Who was that?
Yes, sir.
What do you want? Which one? What do you want from the worksheet?
Just the values which you took.
Yeah,
It's all here in the model file, right? So I extracted all the model file, and that's what I'm saying. if you're not following the worksheet, just let's finish this and you can go back and do your worksheet later on. At least do the model and compare it to just show that, you know, it matches. Okay.
Sir, one thing to ask. Hello.
Yeah, go ahead, Praveen.
Actually, we are intentionally taking the slope in the linear region, right?
Your boss is.
Say that again. Your intention is?
We are intentionally taking the slope in the linear region to calculate all those parameters.
Saturation region, yes.
Actually, anyhow, the tool is calculating the slope for us. From that graph, all we need is that slope and values. So anyhow, in any region, the tool can calculate the slope value. So
No. But see, in the linear region, it is a function of VDS as well, right?
yes, sir.
If you take the square root, you're not going to get a linear slope, right?
Yes, sir.
So, yeah, so that's why we take the saturation region, because in saturation region, the dependency on the VDS is very, very small. So it's almost linear there. Whereas if you take it in the linear region, then the dependency is very high, right? It's almost a you know, so you see on the linear side, it is the VDS dependent, right? So if you do that, then both your VGS and your VDS is dependent. So if you take the square root of that, you know, you're not going to get a constant term, right?
Yes, sir. In order to just to get that models in other regions, so where as we know that we can go through these linear values. What if we can we in order to see the variation in between the graph? What if we model in those regions? Anyhow, we're getting that.
No. Yeah. So Praveen, this is also modeling the linear region, right? Because these are also the parameters in the linear region. So, you know, that's the second part. When we do the IDS versus VDS plus VGS, you'll see that it'll also match the linear region as well. It's not like linear region I have to go back, because in the linear region, what do you need? You need KP, you need gamma, you need lambda as well, right? And you need phi. But you have derived those. But the thing is that if you derive it using linear region, it is much harder to extract those parameters rather than doing it in the saturation region.
Okay.
You got it, right?
Yes, sir. Okay.
Yeah. So it is also modeling this in the linear region. So when I go and do the IDS VDS versus VGS, you'll see that the linear region also will match, right?
Yes, sir.
So Vijayalakshmi, you're saying again and again the blank page issue. Yeah, I'm not sure why you're getting that. I mean, I don't know if honestly, sorry, I've sent a request to Napti, but I haven't heard back anything from them. I'll talk to them tonight and see. Okay, so I think he just replied. Let me see. So the shift key thing is saying, yeah, that's a problem. Just have to reboot. Okay, so I think you guys are running something. So Vijayalakshmi, I don't know what you have. Okay, I know, I think what you guys are doing. For some, can you send me? So I just got a reply saying that this will only happen if you run out of RAM. And the only reason you'll run out of RAM is if some of the sims, like for example, instead of 0.01, you have done 0.01 or 1 nanovolt, or you made instead of 5, you've done 50 or something like that. So Vijayalakshmi, can you open your netlist and send a snapshot real quickly?
Yes, sir. Yes, sir.
So that's my guess, is that you guys are making a mistake in your netlist and you're just running out of RAM. So basically all your machines have only 500 MB RAM. Just remember that. These are tiny instances running in the cloud. Okay, who else is done?
Sir, I'm getting a wrong plot.
Send me a plot.
It's
And
like
your netlist.
the red one is coming directly from the 0, 1. Like the slope is from 0 only, not from the VT knob.
What is your red one? Is it the last M1? I mean M1 or M2?
Yes, sir. Yes, sir. Model 1.
But your model 1 was working fine.
Actually, I think I have done something mistake. I have to go through.
Yeah, it's probably in your netlist.
Yes, sir.
Yeah, send me the picture of your netlist and your plot as well.
Okay, sir.
Excuse me, sir.
Yeah.
Yeah. Sir, I have sent a screenshot of my after writing source extract minus bt dot sp, but it's showing like no such file or directory. Simulation interrupted due to error.
What is that error?
Okay, now you're able to see though, right? So.
What is that error?
Okay, now you're able to see though, right? So. Just getting a bad echo. Yeah, Vijayalakshmi, your netlist looks fine to me. I don't see any problem here. Yeah. Okay, so Vijayalakshmi, now you're saying you're getting an error for this one?
Sir, not error, sir. Sir, that blank page issue.
Which issue?
Sir, it is automatically means that blank page that I have reboot again.
Okay, so is it happening when you're running the code?
No, sir. No, sir.
Okay, it's just randomly happening.
Yes, sir. Yes, sir.
So what is your username? Bijay? Is it Vijayalakshmi or what is your username?
Sir, Bijay, Bijay.
Bijay. Okay, let me just send him. See. So this I don't get it. What is it you are sending? They're just CD. I thought you were getting some error in your NGSPICE.
Sorry, sir. Actually, that was wrong.
Okay. Anyone else able to complete this or not? Okay, hello, good. So are you getting all the plots like we showed
Yes, sir.
you?
Yes, sir.
Okay, good. Who else? Yeah, I don't know if this is your model or yeah, just send me. So this send me your net
Oh,
list.
yes, sir.
I think it's some issue with your net list. How about the rest? You able to complete or not? Stuck somewhere? I hope you guys haven't given up. Yeah, if you're getting errors or anything, just tell us what it is. If it is a simple one, we can ask you to fix it or. Okay, so the first thing you have done is your phi is 0.84K. That's going to make everything go bonkers, right? That should be 0.84 volt. 0.84 kilovolt means everything starts with 0. So this, you see that, right?
Yes,
Hello?
sir.
Okay. Yeah, I think that's your problem. So just fix that and run it again. You should be fine.
Sir,
Yes?
sir, I have also same problem like Vijay Lakshmi. If I reboot, if I reboot, then I come to my Netflix netlist folder. It will showing attention like E325 attention like that window.
Can you send me a screenshot?
Yes, yes.
Yeah, Vijay, can you send me your screenshot as well? No, attention ET, which one? That first one. That one you can just hit OK. Just send me a screenshot real quickly. I mean, to the WhatsApp group.
Now it is not showing in my case. After some time, it will show again and again like that.
Yeah, so whatever you're saying, just send a screenshot. Okay, so I'll just send it to NAPTI. Maybe they'll figure out what's going on.
Okay, sir.
So Sandhya, this is, see, the problem is when you have your file open and your thing crashes, like I was saying to Ashwini earlier today. Hold on, what happened to mine? Open today, then what happens is your swap file gets stuck. So what you do is when you log in next, you get this error, you come out and delete the file .extract-vt.sp. Basically, it's your file name where it has a dot in the beginning and dot SWP in the end. You got it, right? You delete that file and then edit it again, and then it should be fine.
Okay, sir. So dot extract slash sorry hyphen bt dot sp dot swp. I have to
SWP,
delete.
exactly. Yeah, just delete it. Just do rm dot extract dash bz dot sp dot swp. So that's the swap file which is always opens when you open the Vim, and once you delete it, then it'll be fine, because when it crashes, it just creates a stale swap file. Okay, looks like
Okay, sir.
I have the same problem.
Sir, this is also do with mine, but if I refresh it, then on my netlist folder and all are they're getting blank. I have to means type again.
Didn't follow. What is it again?
Sir, I have also same problem like you. I get a big blank black color page, and my whole thing will be not working. Then I refresh again. I press stop and play again. Then I lost all my netlist
Yeah.
folder and
So if you stop it and go, then what will happen is your VI windows will go down. So you have to kill the swap file and start again. I'll talk to now. I think what is happening is, since more people are joined in, then they're just running out of RAM. I don't know why we should run out of RAM, but you just have to kill the swap file and start the VI again. Okay, just like what I'm doing right now.
Yes, sir, I got it.
You got it? Okay,
Yes.
good. So yeah, so maybe people who are having the same problem, just you can follow what I'm doing right now. So this is basically your system has rebooted now, and you start from scratch, and okay, so let me just increase the size a little bit. So CD lab2. Okay, so here you'll see that if I do ls minus al, there should be that swap file. Yeah, you see here. So this, the two swap files. One is this and the worksheet as well. Okay, so the right way to do this is you do vim extract, let's say swap, and you see it'll say open read only edit. Basically it's saying, oh, it crashed, blah blah blah, in order to recover do this and that and this. So what you do is you do recover r, okay, and then press enter. So you'll get, so if there were any changes which were not saved in the file, will be saved now. What you do is you save, quit, and now you delete that swap file, dot extract dot swap, and you say yes. Same thing with the worksheet. I can do worksheet, and I say recover, and hopefully there was no changes. I save it, and I also delete the worksheet dot swap. Okay. So let me open extract.sp and then open a new tab, and let's call this NGSPICE. So yeah, it's a little bit annoying, but hopefully when you guys are doing it on your own, shouldn't be a problem. I think they're just running out of RAM. I'll talk to them today, and hopefully they can fix this. And then, okay, everyone able to repeat this now, or anyone stuck? No questions?
Got the output, sir.
Got the output? Okay. Anyone stuck in some point? I know some of you are facing the blank screen problem. But like as I said, just start over again, recover, delete the .swap file. I know why some of you are just getting repeated on and on again. Like you see, it happened to me again. Okay, so what I'm going to do now is I'm going to quickly show you the Lambda one, and then I'll wrap up, and you can carry on at your own pace, okay? Because it's already 6 o'clock. So I'm going to copy this to a new file. I'll call it cp extract lambda.sp. Okay, open this. Okay, so I'll keep everything same, obviously. It's just that I'm going to extract Lambda now. So I'll keep the model file as it is. And only thing I'm going to do is I'm going to change this a little bit. So if you remember, the drain part remain the same. The gate part, I'm going to call this node gate, right? And so both the gates will be same now. And the drain currents will be the same. Bulk current, I don't care. I'll leave it as it is. But I'm going to add a new source now, and I'll call it VGS. And this will be from gate to source, which is 0. Give some DC value, like 1 volt or something. And now I'm going to vary VDS per different VGS values, okay? So VGS, I'll start from, if I roughly remember, I think 1 volt is, I mean, 0.5 is the VT, so I can do anything above 0.5. So I'll do 1 and 1.5, a step of 0.5. So basically just 2 VGS values, not doing more. Maybe do 0.7. Let's do this first. Okay. And for plotting, I'm just going to actually let the derivative be there. I'll delete this. I'm just going to, now I don't have to do this square root business. I'll just plot both IDs as it is. Okay, so hopefully this should work. So let's start NGSPICE and then do source, extract. I have 2 files, so lambda.sp. Okay, I got some plot. So you can see for the 1 volt, it is quite close. And for 1.5 volt, it is quite different. And this we saw, like as we went higher and higher voltage, it started deviating more and more, right? So Praveen, to ask your question, you can see in the linear region, it is obviously there is a deviation because we are missing a lot of parameters, right? We have 100 parameters in 3v1, we have 5 parameters in level 1. So there will be different, but you can see it's pretty closely matches also in the linear region. Okay. And because our lambda is 0, you can see that let me just zoom in here. So you can see that the level 1 model is just flat, right? Because lambda is 0, it's not varying at all. And if I take the derivative of this, you'll see there will be a kink here. Okay, a little bit of a kink here, but it is still going to be very continuous. And this is the real model. Okay, so now let's derive the lambda and put it in the model and see if the lambda will match closely or not. So I'm going to zoom in, around here. Okay, and I'll take the slope right around here. Okay, let me go back to my NGSPICE window. So you can see I get x0, y0, x1, y1, and the slope as 2.13, and this is microamp per volt, basically, right? The slope. Okay, and you remember, right? We are going to, you can use the formula which is given in the book, which it was covered in the last year, but like I said, I'll use another approximate formula. So let's open our new window now. And sorry, not new window, new tab. And this is our worksheet. So I can rename it, but we have only a few minutes. Let's just go to the worksheet. Okay, so we'll calculate lambda. So this is lambda calculation now. And for lambda calculation, I need the slope. So slope is equal to dy by dx is 2.13 microamp per volt. So this is 2.13 microamp per volt. And I naught, like as I said, you can take any of the IDS values because they're not changing. It will be very close. So I naught or equal to IDS. And you can see that, I have two IDSS values here, right? 73 micro, 72.36 micro. I'll take the lower one, okay, because it will be closer to ID0. So I'll take you can see the difference is not huge. So if I take the slope divided by this or slope divided by this, they'll be very close. So I'll take this number, which is 72.36 micro. 72.36 microamp.
Sir?
Yes?
Sir, actually in first case, we have done some mistakes like that root over of 2 5, I guess. That is.
Where is it?
The plot actually. We have done that 2 multiplied. But that 2 should be inside that root over. But we have
Yeah, it was
multiplied that
inside the
out.
root over, right?
Yeah, but we have done that outside the root over multiplied.
When you say we means who is it? I or you?
I don't know. Maybe I have done that. I don't know that you have done.
So why are you saying we? You should say I first, right?
Yes.
Okay, let's see if I made the same mistake too. Yeah, it is inside.
Yes, inside it's correct.
I have done this.
So first say I. Why are you blaming me with you?
Sorry, sir.
So you said we have made bunch of mistakes. So that was one. Let's go to the next one. What's the next one? So what's the next one?
So which one?
No, you said we have made a couple of mistakes. So that was the first one. So that's your mistake. We haven't made that mistake. So what's the other one? What's the
No,
other
sir.
mistake we did?
So I said we have done one mistake.
Oh, you said one. Okay, I thought you said bunch of mistakes.
No, sir.
Okay, so slope is, okay, we calculated that. So lambda is going to be slope divided by I0 or I dash. And the slope is, so since both of them are having microamp, so I'll just keep the units out. And so it'll be 2.13 divided by 72.36 1 over V or volt inverse, right? So which is equal to 2.13.
You wrote it reverse.
72.36. So 0.0294. 0.0294. And if I did take the other current, for example, so I'll show you 2.13 divided by 73.6, 73.6, it would be 0.289 instead of, what is it? 0.294. So like I said, you're as in a first level, obviously it's going to differ, but on a first level, it is almost close. So that's why I take the lower number. So this one will be more closer to reality. 0294. Okay, now let's go back to the net list and change the lambda. Hope I'm in the right net list. 1 second. Yeah. Change the lambda to 0.294 and let's rerun this. Okay, like I said, this one obviously but now you can see this has a slope also, which is hold on a second. So you can see now the slopes at least match. Obviously, there is a little bit of a difference in the current because of other parameters, but you can see the slope matches now. And you can also see the derivative. If I did it here, there will be a kink here. Whereas in the real model, it is very, very smooth, right? So, now you kind of get a feeling like, what all it takes to do the real modeling. So this is just 5 modeling. In order to get it close to what the physical model is, you have to do a lot more measurements, lot of adjustments. And, next week when we cover some of the short channel effects, once you get used to the modeling and all that, we'll do short channel effects. That's when we'll explain to you some of the big short channel effects. Like for example, when we did the derivation, I said V is equal to mu times E, that is the velocity, terminal velocity of your electrons are mobility times electric field, but it's not true for high fields. So once the fields get really, really high, your mu is going to saturate. In other words, I mean, your velocity is going to saturate. So that's why in short channel, your velocity saturation happens first before your VDS equal to VDS minus happens. So your constant current actually starts happening earlier. In other words, your current starts lowering than what your long channel currents are showing you. So this is only one effect, like the velocity saturation is one effect. Then you have mobility dependence on the vertical electric field, DIBL effects, and so on. So we'll talk more about it. But at least this gives you an approximation that the level 1 models are approximate. It's good for hand calculation to get you close to ballpark numbers, but in order to get the real result, you have to use the real models. Otherwise, you'll be quite off. When your chip comes back, it won't be anywhere close to what you had designed for. Okay, so I was hoping I get to this PMOS part, but now you have to do the PMOS part on your own because we kind of went slow, but it's okay. At least people are slowly getting the hang of it, but you just have to practice more because the labs are going to get a little bit more intense, and the more you practice, the more you can get along and be with the lab. Otherwise, it will be. And some of you are having lab problems. That's unfortunately, it's very little we can do from our side. But I'll talk to NAPTI today and see if it's something it is on their side or it's something we can fix on our side. I really don't know. I mean, it seems like it might be a resource issue, but we'll see.
Sir, just open that worksheet. Yeah. So here in the 5, just insert 1 2 before 26 millivolt. It's not error, just missing that.
Oh yeah.
Okay.
Yeah, it is already calculated here, but we
Yes.
didn't have the room. Okay, so yeah, hopefully everyone. So this is how I would suggest: open a worksheet, keep all the numbers here, because then your simulation and all your calculation remains in one place. So tomorrow, people who are interested to carry on this work and keep this work, like as I suggested, maybe one day I'll just do a half-an-hour demo where you first create a GitHub page and have your repo ready, and I'll show you how to sync it. So that way it'll go onto your GitHub page. You create a nice README file like you have been seeing, like, how our course page is like this. You just create and you can insert figure plots here. People actually now maintain all their projects this way, even IC design. If you, like, for example, Kunal goes, if you follow his course, people all, do maintain it here. So this way, you'll have it in one place, and you can give this link in your resume. So when you send your resumes, if somebody wants to see, he has a link, I wonder what he did, he'll click this. And if you have a nicely documented with results and all that, trust me, it is so impressive. If I get a resume and somebody has, like, I did 7 nanometer, place and route, blah blah blah, something written on it, but somebody has, like, I did a parameter extraction thing, and there's a GitHub page, I link it, I see these beautiful plots, I see nice equations and all that. I don't care about the 7 nanometer design, because it's like the old saying, right? To a bird in the hand or two birds in the bush. I don't care about the two birds in the bush. I see what you have, and that's just very, very impressive. So that's what I would suggest. Take the problem statement, because in the problem statement I've also given the PMOS. I've also asked you to do short channel, like reduce the channel length to 0.5, and see, you'll see this high voltage effect is even larger, right? We took channel length of 1 micron to reduce the short channel effect, but you can still see the effect of it. Now you go to 0.4. Actually, this technology allows you to go to 0.4. Go to 0.4 and do the same thing. And so go through the entire exercise and create a nice document, like a 3-4 page document, put it on GitHub, and it remains, it'll remain with you forever. And next time you want to do this lab somewhere else or show it to, you just have to do a git pull, start using it again. Like people who wants to, um, somebody asks, can I use this in my virtual box? Yes. So now you go to your virtual box and do a git pull and start working there. You have all your work just exactly the way it is. And so that's that. I'll strongly, suggest that. Um, and yes, just finish this, what we did, and do it for PMOS. And you have to do it for PMOS because, PMOS is, as you saw, it's a little bit more confusing. Um, the biasing is a little bit more confusing. So if you do the PMOS, then that's it. You'll not have any issues with, design and finding regions of operation and, basically analyzing circuits. I mean, there's still a lot to it, but at least the basic part, you're not going to get stuck with it. All right. Any questions?